Hi, everyone, and welcome to the fourth and final video for week one of EG1311 Design and Make. In this video, we're going to be talking about the template projects that you and your team are going to be working on in tutorial one and hopefully have completed by the start of tutorial two. So what is this template project? Well, it's really a way for you to build something first that you don't have to design that allows you to see something working in the lab. So you're concentrating on the building, kind of the handcraft of making a robot, and you don't have to worry about designing your own at first. It's like, instead of having you design a Lego set, we're giving you a Lego set first to be able to build from the instructions, and then you're worried about designing your own thing later on. So at the end of term, we're asking you to give us a bunch of things in a report appendix, like an image of your final robot and a CAD drawings of how to cut things, a circuit diagram, and our Arduino code, so that someone else would be able to build your robot. So for the template project, we're basically giving you that whole thing to start with, right? So we're giving you that report appendix so that you can make this template robot yourselves. And it's an example, essentially, of what an appropriate report appendix would be. Now, the CAD drawings that we're giving you are not fully dimensioned because we're printing them out for you, but yours will need to be fully dimensioned. So we're not giving you just an image of the template robot. We actually have a video here for you of the little template robot in action. So here, if we take a look, we see the template project running across one of the laboratory tables and stopping when a hand is put in front of it. And so it can roll forward. The Arduino sends power to the motors, but turns off that power when the ultrasonic sensor senses something in front of it. So that's the template project. And you'll see that the template project is mostly made out of cardboard. So don't worry about using up your cardboard because, again, you can use as much cardboard as you want. But all of the components here are made from cardboard, the mechanical components. And so here are templates that will have printouts for you on A4 pieces of paper in the lab. You don't have to worry about printing these out. We will have printouts of these for you that you're going to need to cut out and attach to the cardboard and cut out so that you can make the body and the wheels of your robot. And we're going to see in this video a demonstration of how to do those things. And then here is a circuit diagram and the code that went into making that robot do what it did. So essentially what we have, a couple motors here. We have a 9-volt battery pack, which is powering everything. We've got our motor driver here. Don't worry about why these connections are made the way they are. Just be aware that where these connections start and end is pretty important when you're wiring this up. So you can wire these things up blindly in tutorial one if you haven't been exposed to the week 3 lecture material yet. So you'll have no trouble, following this diagram and putting these connections in, but you may not understand why you're doing that or what these things are until you get to week 3. Now, one note on the ultrasonic distance sensor, you'll see that we have 4 wires going from here to these pins down here on the breadboard. That's just because normally what we'd have is to not have these wires here at all, but plug these 4 pins into these 4 holes on the breadboard, okay? It's a little messy there, but all of the connections here should be connections here. And so in actuality, when you're working on your template project, you probably don't want to use any of these wires. What you want to do is plug this ultrasonic distance sensor, these 4 pins here, into these 4 holes, okay? But why did I diagram this for you in this way in Tinkercad? It's because if I put this ultrasonic distance sensor on those pins in Tinkercad, then I would actually cover up all the wiring that's below it. So this is just to show this without covering up the rest of it. But what you'll want to do is not use these 4 wires here and just plug them directly into those breadboard holes so that the speakers, these little eyes on the ultrasonic distance sensor, are pointing to the right, stuck in right here. You should not bend the pins on the ultrasonic distance sensor so that it's lying flat so that the speakers are pointed up like they are on this diagram. You'll have it oriented so that the speakers are pointed to the right and the pins go straight into those holes. And this right here, this is the code that you're going to put on your Arduino to make the template project behave in the way that we saw before. Okay, so again, you won't know what any of this code means until you've finished the week 3 lecture videos. Okay, so that's the template project. Those are the appendix deliverables that we're giving to you. And what you're going to want to do in tutorial 1 are a bunch of tasks. We're giving you batteries and we're giving you wires and we're giving you battery holders and motors, but none of these things are hooked up in an easy way that we can connect them together. And so the first task you guys will have in tutorial 1 is to connect each of your motors and the battery holders to jumper wires so that you can easily plug them into the breadboard. And so we're going to have a demonstration of how to do that later in this talk. Then you're going to have another set of tasks which involve cutting out the sheet material, namely the cardboard, from the templates that we're giving you and folding up that cardboard into the structures that we'll be using for the template project. And then the last kind of task that you'll have to do is wiring up electronics and uploading code to the Arduino board so that everything's going to be able to talk to each other once you get to tutorial 2 to show your tutor that your template project runs. Lastly, you're going to attach those motors to the body and put all the electronics onto the body and test it out. Okay, so why have I boxed these 3 different tasks up here? That's because you have 6 people in your group. It's very easy to get all of this work done very quickly if you can separate these tasks and have people doing them in parallel, and you'll get done with that work a lot faster. So I would suggest assigning 2 people to each of these tasks. Of course, one person could do this whole template project on their own in 2 hours if they kind of knew what they were doing. But you guys are new to this, and so I would suggest you work in pairs and maybe even do this template project once or twice or 3 times with all of the members of your team taking on a different role so you can have that hands-on experience with each of these tasks. Okay, so we're going to go through some video tutorials now of doing each of these tasks. We're not going to go into a lot of detail of the wiring up the electronics, but we are going to go into a little bit of detail in terms of wiring up your motors, wiring up the battery holders, and cutting and folding the cardboard templates. So we're going to start with wiring up one of our motors with one wire connection. So here's a motor and a wire that we're going to try to connect. And the idea here is we're going to first start with the wire. We're going to cut off one of the ends here. Now, right now I'm using a male-male wire and I'm cutting off one of the male ends. You're also welcome to connect a female end to your motor, cutting off a male end of one of your female-male wires. It's really up to you on what wires you'd like to attach to all of your components. A benefit of attaching a male head to your motor connectors is that you can plug it directly into the breadboard. A benefit of having a female end at the end of your motors is that you can extend it using a male-male wire. And then you also have a nice place to detach the connection to your breadboard that's away from your breadboard. If you want to do that, that can be very convenient. Right now, I'm hooking up a male-male wire. I'm just cutting off the end there. And then I'm going to strip the plastic shielding that's around the wire. And what I'm doing is I'm just rolling my penknife along the outside of that thing. Careful not to cut the wiring on the inside, and then just pulling away that plastic shielding. Now, there are also some wire strippers in the lab that if you ask your TAs or the lab staff to teach you how to use them, they can teach you. But I would ask you that you please not use the wire strippers until they've taught you how, or else you might pinch or cut your finger when trying to use them. So it's easy enough to score off the plastic shielding with your penknife. And so that's what I've done here. Now, when you strip the wire from the plastic shielding, what you'll notice is that the center of that wire is not just one thick, large gauge wire in there. It's actually many very thin wires all bundled together, right? And this is what we call a multi-threaded wire. And it's designed that way because if we had one thick, solid wire of metal in there, then if you bent that wire back and forth, that metal would fatigue and break. And then there would be a broken connection in the middle of your wire, and suddenly your motor's not working or some component of your electronic stuff is not working, and that'll be sad. And so having many wires in there that are a small gauge will allow these things, when the wire bends, to slide relative to each other. And so it's much less likely that these things will break in normal use. So that's why you've got all these little wires in there. But because you've got all these little wires there, it's going to be difficult for us to thread these wires just like this into things like the hole on the motor connector or connecting it to other wires. So what I would suggest you do once you've stripped the wire is to twist all of those little wires together around each other so that it acts like one solid piece of wire. And so I'm just twisting that there. And now it's going to be very easy for me to thread that little wire into the hole on the motor. I just take that motor here and I stick that wire into the hole on one of the leads of the motor. And I'm just going to bend over. I'm going to hook over that wire onto that motor and twist it around so that it makes a secure mechanical and electrical connection onto the lead of that motor. And so the hope is that even without doing anything else right now, I'm just pulling it away from that motor wire so you can see that as a solid mechanical and electrical connection, that thing is not coming off of that motor because that wire is wrapped around it. Now, this isn't a strong connection right now because the wire can still move back and forth. And so what I suggest you guys do is to cover all of the metal contacts there with your hot glue gun. So we're just slathering hot glue all over this metal connection. You can even kind of spread it around there so that it really covers everything there. And you just let that dry. And once you've completed that, then you're done, right? Wiring one lead of your motor. You're going to want to do that on the other side of your motor as well to the other connection. Now, a lot of students will ask me, Jason, why is it that we're not doing the normal thing of connecting wires to motors and other electronic components by using a soldering iron and solder? There's a couple reasons why we don't allow solder in this class. First is that there's safety and training that have to go along with using solder that we don't have the manpower to provide. The second one is you can't solder outside of the lab, and a lot of the work you're going to be doing on these projects is going to be done outside of the labs. And so if you can only solder when you're in the labs, then you don't have a solution when you're outside the labs. So we'll be teaching you this method anyway. And then the third reason is that it's really important that because you're going to be prototyping and redoing these things throughout the term, it's really important for you to be able to revert your materials back to their original form so that in case you get stuck or you want to throw away your design and redo everything, that you can fix those things on your own. And it's pretty hard once you've soldered something on. There's an art to, remove those connections and clean it up so that you can then rewire your things. And also putting hot glue all over it also provides some electrical shielding that you wouldn't normally have with soldering. So we're not allowing soldering in this class. And actually, if you do this correctly, then you'll have no problems. The difficulty we have is that a lot of students in tutorial 1 will not take the time that they need to do their wiring well, not making a good secure mechanical and electrical connection, not covering it fully with glue so that it has exposed parts to the outside or the mechanical connection is not good. Not doing those from the beginning leads to problems later on. So I would suggest that you have time in tutorial 1 to do nothing but this kind of wiring stuff. And so spend the appropriate amount of time to make these things good so that you don't have those problems in the future. Okay, so that's wiring on the motor for one of the leads. You'll do the other one, as well as doing the same process to all 4 of your motors. Then we're going to attach jumper wire heads to your battery holders as well. For the template project, all we need is the 9-volt battery holder, which is this holder right here. But eventually, you'll need to wire up your AA battery holder as well, so you might as well get that over with in tutorial 1 as well. So here, we're just going to show that same kind of process. First, what we're going to do is take each of 2 wires. I would suggest using red and black for the kind of convention that a red wire is a positive voltage and the black is ground. And what I'm going to do is I'm just going to cut that in half so that we can use those other jumper wires for the AA battery pack. And what I'm going to do is cut that in half and strip each one of these wires, again, just using my penknife to score the outside plastic shielding. And then I'm going to twist those wires up, as we know, because it's going to be a lot easier to deal with later on. And now once I've twisted that all up, I'm going to strip the end of this battery holder a little bit as well, so that I have a little bit more wire to work with. And then I'm going to make a little hook on either side of these wires so that I can attach them to each other with a strong mechanical and electrical connection, hook them together, and then twist them. And if you do this well, then they've got a good electrical connection, they've got a good mechanical connection. I can even pull them apart like this, and they're not going anywhere. So we've got a good connection as it is right now. And then lastly, what we're going to do is cover that connection in hot glue so as to electrically shield it from the rest of the world and make sure that that mechanical connection is not going to fail. And right now, you'll see I'm putting hot glue all the way around that thing and just having it dry on my cutting mat, because once the glue is dried, you'll be able to easily just lift that up off of the board, trim that off with a penknife. And you'll see that metal is not showing. It's completely shielded on all sides. And I can just trim away any excess glue that I have. I have a nice wire connection to a jumper wire for my battery holder. And I'm going to do that on the other side as well, just stripping this black wire, making 2 hooks. So making a hook on one end. I need to strip the black wire as well. Twist that up. Make a hook on one end. Make a hook on the other end. Slide them into each other. Twist them up so that make a good strong connection, very strong there. And again, coating one side with glue, turning it over, coating the other side with glue, letting it dry, and then removing it and trimming away the excess. So that's all done with my 9-volt battery holder. It looks great. That's going to work very well for my purposes. And then we're also going to do the same thing to the AA battery pack as well. But we're not going to need that for the template project, but you might as well do that in tutorial 1 so you can get it out of the way. Okay, that's wiring. Next thing we're going to be talking about is cutting out the cardboard templates. The cardboard templates here, we've got in A4, and what I'm going to do is I'm going to just start with the body template and cut out the bounding box of that template using my penknife and a ruler, just like so. So I'm cutting along the bounding box, which is in these very thin black lines on the diagram. And actually what you'll notice on this thing are kind of some solid black lines. Those are going to be lines that we're going to cut along. And then you've got these 2 types of broken lines. One's a dashed line and one's a dotted line. And the dashed lines and dotted lines are just fold lines, places you're going to fold up this template. And the important thing is that it doesn't really matter which is which. Suffice it to say that one's going to fold one direction toward you, for example, and one's going to fold in the other direction away from you, right? So all of the dashed lines might fold toward you and all the dotted lines might fold away from you. Okay. So when we're going to cut out the body from the cardboard, we're not going to want to cut along those broken lines. We're just going to want to cut along these thick, solid black lines. Okay. So what we're going to do is take the bounding box that we just cut out. We're going to tape it onto a piece of cardboard and then cut out the bounding box on the cardboard. And again, I'm cutting against the grain first And then here, this is with the grain of the cardboard. And I'm aligning the cardboard so that the grain is going along the direction of the long side of the template. Here, I'm just taping on that paper onto the cardboard so that when I start cutting out the template of the cardboard, I can cut through both layers and these things will stay aligned with each other because they're taped together. And you'll notice I've put tape on parts that are not going to be cut away in the final template so that they stay connected throughout the entire process. Okay, so once I've taped those on, now I'm going to cut away those solid black lines on the template. And like my advice was in the last video, I'm going to cut against the grain all of these things that are going in the short direction of the little template here before I do any of the cuts along the grain, which is parallel with the long side here. So I'm just going to take my penknife and cut. Notice that I'm cutting against the grain here, and I'm just cutting each of those things. You can use your ruler as well to help guide your cut, but these are relatively short penknife strokes, and so I'm just doing that without a ruler here. So I've cut away all of the lines that are against the grain. I'm cutting these diagonals and then starting to cut all of the lines that are with the grain. Those two long lines are with the grain. These are with the grain, as are all of these. And here, while I'm going, you'll see that some of the material is being cut away. And that's okay because I can still see where the lines of the template are. So I'm just cutting through all of the various parts here, cutting those out, and you'll see it's cut off here a little bit, but you know the drill. It's all the same as on the other side. I'm just removing all of that excess material, just like this. But it's important that with the body template here, that we not remove the paper template yet, because what we want to do is transfer those fold lines onto the cardboard. We're going to do that by using our ruler and maybe a ballpoint pen and just score along, just draw along those fold lines to transfer a small indentation onto the surface of the cardboard so we know where those fold lines are when we go to fold this up. Now, it's important not to press too hard with your ballpoint pen. You can easily rip through the cardboard. That's not what we want, but we do want to make sure that there's an impression there on the cardboard surface so that we'll be able to see the fold lines when we go to fold. So now, once we've done that, we can remove the template from the cardboard, and you can just rip that off, really. Be careful when you're taking off the tape because it can take a little bit of the cardboard with it. And once we've removed that template, now we're going to fold it up. So here's the cutout template. I'm just going to make sure that all of the the cuts are separated from each other. And then I can actually use the ruler that I have as a guide to make these folds very precisely, right? So I can just put that ruler at the edge of where those template lines are and use it as a guide to fold it up. And so what you'll see is at the front of the robot here, you see we've made 3 folds, which combine to be able to make this tab go into a pocket. And we'll do the same thing on the other side, this time folding one over and these tabs over. And those tabs are again going to go into these little pockets on the other side. And you can see folding those folds will put those tabs in the pockets, right? Now, unfold that so that we can do the sides as well. We can fold up the sides, which will then go into those pockets, wrap around them to make a nice box structure. So we take these 2 tabs, fold them into the center, and then fold the nice long thing with the grain. And then we wrap those tabs around the front and put that final tab in the slot to make a secure connection. So this template body will actually fold up without any glue, without any tape or anything. But if you'd like to add glue or tape, you can do that as well. So again, we're making that little thing for the back of the robot to rest, and then sliding those 2 tabs into the 2 pockets below these triangles here. Okay, so that's how you fold up this little template project body with the dragger at the back. which is going to allow the template project to move forward. Once you've folded that up, then you're going to cut out the wheels as well. So you could have someone else doing this in parallel. Again, I'm going to follow the same procedure I did with template body, which is to cut out the bounding box of these templates so that I don't have all this extra paper, each wheel individually. So I have that wheel cut out, and now I'm going to just attach it to a piece of cardboard with tape, and then cut out that cardboard on the bounding box so it's a little easier to work with. Now, could you cut the template directly from there? Yes, you could, but I think this is easier. So I've cut against the grain there first, and then along the grain, because against the grain, it was going to be a harder cut to make. But now once I've got this, template taped onto the cardboard and it's cut to the right size, the wheel is relatively symmetric. And so it's not going to matter so much if I'm cutting with the grain or against the grain right now, but I am going to want to start cutting the hole for the motor coupler to start, because that's in the center. And generally, you're going to want to cut the center details first before you cut away the outside, especially since the outside is where we've taped. So we're going to start by cutting the motor coupler hole here. And you don't need to cut along the center hole there. That's going to be on removed material. But what I do is I cut away the long edges of the motor coupler and then cut this round feature on each end and then just pull out the cardboard. Then what I'm going to do is take each one of these four corners and trim them off, doing my best to traverse along the outside of that circle so that I now have a wheel. And there's my wheel. You might have a little excess tape, which you can then take off. We've got our wheel. Okay, you're going to do that twice. You're going to cut two wheels. Then you're going to wire up the breadboard and the Arduino based on the circuit diagram that we had. You're not really actually supposed to get anything from this video per se, because it's really hard to see where all these wirings are, and actually the locations of where these holes and connections are being made is not identical to the wiring diagram that you had in an earlier slide. And that's because it doesn't really matter where these connections are on your breadboard. What matters is what connections are being made. And so if you don't understand what I'm talking about right now, wait until week 3, and hopefully you will. Otherwise, when you're wiring up these components, try to follow precisely what's going on in the circuit diagram that we've given you into the right pins on the breadboard so that everything's going to be wired up correctly. So that's wiring up the thing. Then you take the body, you glue on your wired up motors here. I'm just going to hot glue them to the base of the body. And the hot glue is really nice here because once I'm done with the template project, I can actually peel off the hot glue from these plastic motors and they'll be just as good as new. That's one of the benefits of using hot glue as opposed to some other adhesive. That said, hot glue is not the strongest of adhesives. And so when you're gluing it to something like cardboard, it's really important to try to get those two surfaces clamped next to each other as soon as you lay the glue down while the glue is still hot. As the glue cools, it gets less and less sticky. And so if it's on there too long before you press these materials together, it's not going to make a very secure connection. And I would suggest that you wait for 5 or 10 minutes with these things clamped together before you know that the glue is dry and that connection is secure. So I've glued on one of the motors, we glue on the other motor, and we're just going to thread those motor wires up through that hole in the bottom of the template. We attach the motor couplers onto the motors. We attach the wheels onto the motor couplers. And then we once we have both of the wheels connected, we stick all the electronics in, we connect the motors into the breadboard, hook up the 9-volt battery, and we should be good to go to demonstrate your template project to your tutor at the beginning of tutorial 2. So that's the template project. There are soft copies of the cardboard templates and the circuit diagrams on Canvas, but you'll also be given hard copies of those in the lab. So no need to print those out before you come to lab. But with that, hopefully you are all successful by the start of tutorial 2 in completing your template project. Hope you have fun doing that. And I also hope that you look at it with a critical eye, because it's not a very good robot, but use it as a starting off place to see how you can improve to make a robot that will complete the course. So that's the template project. That's the last video for week 1. So just stay for a brief quiz.